Oh, okay. That sounds great. How about you, Sophia? How's the homework going? Well, that's good. How did you feel about it? Good. All right, we'll give Jack a minute or two to log on. Did you guys have any questions in 3.1 or 3.2? That's good. All right, I'll just give him a minute or two. And I think what I'm going to do today is just go over a few problems in 3.3, and then we'll even do a few more on Monday too. You can start 3.3 if you have time, but if not, I mean, it can kind of overlap into next week. So we'll do some of 3.3 today and some of 3.3 on Monday. So we're kind of going to do things out of order too. Like we're going to do 3.3 and then we're going to do 3.5 on Monday. And maybe we might get a little bit of 3.4 in there, but we'll see. Because that one is word problems. Ah. Okay, well, I'll go ahead and get started since I'm recording. So what I wanted to do today is just kind of give you and I know I think I did this in class on Monday too, was give you an introduction to 3.3. So we're going to do a few more examples from 3.3, and like I said, and then we'll do even more in class on Monday too, because I want to make sure everybody really gets this. Excuse me. So basically what we've been talking about is solving equations, right? Kind of the meat of algebra. This is like well, that's an expression anyway, but basically one of those fundamental things that we do in algebra. So we kind of split it apart, right? When we started, we said, first we're going to talk about how do we solve if we use addition or subtraction. And then in 3.2, we said, okay, how are we going to solve if we have multiplication or division? So what we're going to do is we're going to put those both together and say, okay, what do we have to do if we have multiple things going on in the equation? Okay, so we are going to solve a few equations. And I think that I even did this in class on Friday, but we'll do this one again just to be, over clear, I guess. So this is example number 1 on your page. So we have 3 times W minus 7 equals 8. Okay, and all of these algebra problems, what we're trying to do is we're trying to solve for the variable. Remember, my joke is that the variable is like the loner and it doesn't want anybody nearby. So W is our variable, and we want eventually at the bottom, we want to get to W equals something. W doesn't want anything being done to it. It wants to be simplified into what the variable is. Okay, so in order to do that, we have to undo everything that's being done to W. So this is kind of one way to think about it. So right now, W is being multiplied by 3, and W is also being subtracted by 7. Those are the two things that's happening to W. So we need to undo those in order to get W by itself. One of the tricky parts of solving equations, and you can actually do either in either order, but there's a definite order that's easier than the other. So one of the trickiest things to figure out is, what do I do first? Do I get rid of this multiplying by 3, or do I get rid of subtracting by 7? Okay. You can do, like I said, either way will work. One is just going to is going to be way harder than the other way. And I think this is what trips people up. A lot of times they want to do order of operations. So usually we do multiplication or division first and then addition or subtraction second. But what we want to do is we want to actually do the addition and subtraction first, because that's going to make our multiplication and division a lot easier. So that was a lot of words to say. Okay, do I either, I'm multiplying by 3 and I'm subtracting by 7. Which one do I undo first? And what you want to undo first is subtracting by 7. So if I have 3w minus 7, and I want to send that to the other side, the opposite of subtracting 7 is adding 7, right? But if I add 7 to one side, it's an equation, so I have to add the 7 to the other side. Okay, so I have 3w minus 7 plus 7. That just leaves me with 3w. And 8 plus 7 is 15. Okay, so now I'm down, my original equation had two things that were happening to w, right? Now I just have 3 times w equals 15. And you girls might know what this is just by looking at it, right? But algebraically, how do I get rid of 3 multiplied by w? Yes, absolutely. So the kind of the hack, the cheat algebra way is, you say we use our fraction bar for division. Okay, so if I divide both sides by 3, I'm going to end up over here. 3 times w divided by 3 is just going to leave me with w, right? And 15 divided by 3 is 5. So w equals 5. Now, realistically, what we're doing is this, right? Divide by 3 equals 15 divided by 3. We just don't tend to write it like that in algebra. We tend to use the fraction bar for division. But that's, we're doing the same thing, right? Multiplied by 3 was multiplying w, and now we need to divide it by 3. So that one kind of makes sense. Okay. I just want to show you really fast. I'm not going to sit there and explain every little step here, but I'm going to erase a few things off here. You know how I said you want to always start with the right thing? I'm going to show you that the other way works, but that it's a lot harder to do. So if I have 3w minus 7 equals 8, okay? And I said, okay, well, it's being subtracted by 7 and multiplied by 3. So I'm going to divide both sides by 3. So if I divide both sides by 3, I'm going to get 3w over 3 minus 7 thirds equals 8 thirds. So this becomes w minus 7 thirds equals 8 thirds. And then I'm going to add 7 thirds to both sides. And you'll end up with w, if 8 thirds plus 7 thirds is 5. W equals 5. So it works both ways, but can you see how the red side is a lot cleaner? You don't have any fractions. And this is a pretty... Yeah. So that's why I'm saying you want to make sure there's kind of this unwritten order to it. And usually what you're going to do is you're going to, this is my variable, right? My 3w is in that term. That's called a term. So usually you're going to get everything that's not in that term away first, and then you're going to deal with what's being multiplied or divided. And you'll see that as we practice. And that's why we're going to do lots of practice so you can get the feeling, which one do I start with? Okay. So let's try example number 2 on your paper. Okay, so this one actually has a negative out front of it. I don't know if it copied through on your paper. But it should be negative, here, let me grab a drink. Negative 7x minus 9 equals negative 23. Okay. So right now, x is being multiplied by negative 7 and it's being subtracted by 9. So the trick is, do I get rid of the negative 7 first or the subtracting by 9? The 9, yep, that's right. So what's the opposite of subtracting 9? Adding, right? So I'm subtracting 9. I'm going to add 9 to the left-hand side. But if I add 9 over there, I've got to add 9 to my right-hand side. So I end up with negative 7x minus 9 plus 9 is 0, right? And negative 23 plus positive 9 is going to give me negative 14. Okay? Well, sorry, I can barely hear you, Sophia. Close, yeah. So now, right now, x is being multiplied by negative 7, right? So we want to do the opposite of that. We want to divide by negative 7. So the negative can go along with your 7, right? Yep, exactly. So a negative 14 divided by a negative 7 is going to give you positive 2. Is that kind of clicking? Awesome. Okay, so let's try number 3 on your examples here. Purple, right? You've got 1/3 times f minus 8 equals 10. Okay, so f is the one that's all by itself, or f is my variable, right? It's my loaner. I want to get it by itself, figure out what it is. Right now, f is being multiplied by 1/3 and subtracted by 8. So which one do we want to send to the other side first? Uh-huh, yeah, absolutely. Nice, Sophia. So you want to get rid of the 8, right? Subtracting 8, and you're going to do that by adding 8 to both sides. Okay, so then we're going to get 1/3 f equals 18. Okay, so now 1/3 is being multiplied by f. This is where it's tricky. Before, when we just had, like, if it was 3, we would just divide by 3. But we've got a fraction now. We could technically divide by 1/3, but that's kind of funny So we're going to use another tool that we have when it comes to fractions that helps us get rid of fractions. Do you remember what that one is? I think, Olivia, you said it in class on Monday. The reciprocal, yep. So, yes. So instead of thinking I'm going to divide by 1/3, what if the reciprocal of 1/3 is 3, right? Or 3/1? Because 3 times 1/3 just gives me 1. So if I multiply that side by 3, I have to multiply the right side by 3, right? So 3 times 1/3 times f just leaves me with f. And 18 times 3 is 54. Yep. Okay. So then how do I check this? We didn't do this on the other ones. I plug it back in. 1/3 times 54 minus 8. Does that equal 10? 1/3 times 54 is 18 minus 8. And that 10 equals 10. So I always tell my students, I expect you to get all these right because you can check them on your test at least, right? Every homework problem, it would take a long time to check. But you can always check these problems and see if they're right. All right, so let's do one more. We'll do number 4, and then what we'll do on class on Monday is we'll do even more examples, probably from your homework, and then we'll do some of the tricky ones at the end. Okay. So number 4 gives another little kind of difference in solving. We have t minus 5 divided by 3 equals 11. Okay. So now we got to figure out how to get t alone. Now I told you guys, oh, well, we always get rid of our addition and subtraction first, right? It's not always exactly true. What we're really trying to do is trying to do the easiest way possible to get rid of all of the things that are happening to our variable. So right now, t is being subtracted by 5, and t minus 5 is also being divided by 3. And that's the whole thing, not just t. Do you see that? So this 3, another way we could write this problem is t divided by 3 minus 5 divided by 3. So this dividing by 3 belongs to both equations. So we could rewrite it like this and solve for t. That would be one option. Another option is, can we, since everything is being divided by 3, the opposite of being divided by 3 is multiplying by 3. So what if we multiplied everything by 3? How would that help us out? Well, I have 3 times t minus 5 divided by 3, and I get to cross out being divided by 3. That's a major bonus because I don't have to deal with fractions then, right? So I'm just left over with t minus 5 equals 33. So now this is easy, right? How do we solve for t? Right now it's being subtracted by 5, so add 5, right? T equals 38. All right. So what do you ladies think? Not too bad? Okay. Would either Okay. Do you guys want to see any more examples, or you feel like you're ready to go take on the homework? Okay. Okay. Well, then I won't take up any more of your time. I'm sure you guys have a lot to do. But if you do run into questions, bring them to class on Monday, okay? What's that? I can't understand. You're like super faint. I'm sorry, Sophie. Yeah. Oh, yeah, yeah. Yeah, it was just us girls today. Sorry. Your voice is like really far away from me for some reason. Yes, I know. The Jake and Jack. I knew that Jack wouldn't be there. I think he's playing soccer this weekend. No, Jake is playing soccer this weekend, not Jack. All right. Well, have a good weekend if I don't chat with you sooner. All right. We'll see ya. We'll see you Monday, right? All right. Take care, guys. Bye.